Alright, we're back at it again with lesson 10.2, talking about arcs today. So this is how we spell arc. It's A-R-C, not A-R-K. A-R-K is like Noah's Ark. So, we got some terms we need to talk about. So I've got a list of them here down below. So we got central angle, arc, minor arc, major arc, semicircle, congruent circles, congruent arcs, and then we have something called the arc addition postulate. Okay, so let's just look at those one at a time. First off, what in the world is a central angle? Alright, so a central angle, let me draw it for you and then describe it. So we have circles, this whole chapter is about circles. And here's the center of my circle. Center goes with central. And then I'm going to draw an angle. Okay, so there's my angle. Okay, so that's a central angle. A central angle is an angle whose vertex, remember the point of the angle is called the vertex. The vertex is at the center of the circle. That's what a central angle is. The rays as they come out are going to be radii. Remember, radii is plural for radius. So this is a radius, this is another radius. And we don't really draw the whole ray. We just kind of stop with the segment here. Okay, but that's a central angle. An angle whose vertex is at the center of the circle. Now that's going to be important as we get to some other stuff later on in this lesson. Okay, so now let's talk about what an arc is. An arc is just part of a circle. Okay, so got a circle here. Let's say that I just have from like that point to that point. We kind of try to darken this up. I don't know if you'll be able to see it darker very well in the video, but that. Yeah, that looks pretty good. Okay, so that's an arc. It's just part of that curve. Okay, and we could do bigger arcs and smaller arcs. We have something like this. So maybe I start here. Instead of going this way this time, I work all the way around this direction. Okay, so that's like another arc. Okay, all the way up to there. If you use your compass, grab the compass here, and I were to stick the compass down here, and I just draw something like that, that's an arc. Okay. So it's just part of a circle. I didn't even bother to draw the whole circle, but that's an arc as well. Most of the time we draw the whole circle and then we just put some points on it. We talk about which arcs we want, but you technically don't have to. It's just any part of a circle. Okay, so what's a minor arc? Well, I actually already drew it. This one up here is a minor arc. Minor kind of has the idea of not as important, major, more important. And in this case, it's more of a smaller and a bigger idea. Okay, so this is a minor arc. And this is going to be a major arc. A minor arc is an arc that is less than half of the circle. Its measurement is going to be less than 180 degrees. Okay. Now, a major arc is going to be more than half of the circle. It's going to be more than 180 degrees. Okay, remember a circle is exactly 360, and cutting a circle in half we would get 180. Okay, so a minor arc is less than half of a circle. A major arc is more than half of a circle. Now, how do we name them? So let me draw kind of a better circle over here with some letters on it. So we got A, B, maybe C over here. Okay? So if I want to just talk about this arc right here, that's a minor arc. Okay, the way we would name that is we would write the letters A and B. Okay, we're going to start at A and we're going to stop at B. But we can't draw like a straight thing over it because that's a segment. We can't put arrows because that's lines or rays depending on how many arrows we use. So all we do is we draw like a curve over it. That's arc AB. So that's how we name arc AB. Okay, well what if I wanted to name this one right here? Is that more or less than half of the circle? Okay, well once again that's less than half of the circle, so that's a minor arc, so that would be AC. And you could put it backwards, that's okay. You could say CA. Well, what if I wanted to name this one all the way around this way? Okay, that's more than half of the circle. I'm still going to start at A and I'm going to stop at C, but I can't just say this. Anytime you just use two letters for an arc, it means the shortest arc, the minor arc. So if we want to come this way, we need to say A, B, C. Okay. I'm going to start at A, I'm going to go through B, and I'm going to keep going until I get to C. But I can't like start at A and come through B and then cut across the circle. That's not an arc. It's almost like an angle if I would come straight and across. And we're going to deal with that kind of angle later on in this chapter. All right, an arc has to stay on the circle itself all the way around. Okay, well, what if we had something that kind of looked like this? A, B, C. What if I want to start at A and come to C here? Do I have to say A, B, C? No, I don't. I can just say AC. I'm going to start at A and I'm going to end at C. And because it's only 2 letters, I'm going to go the shortest possible way, which is that. So I don't have to say I'm going to go through B. Right? Anytime you're dealing with a minor arc, you can use 2 letters. When you're going to use 3 letters, is for a major arc. Okay, so this ABC is a major arc. Okay, this ABC is a minor arc, so I don't need the B. I can just say AC. All right, so a minor arc, remember, is less than half of a circle. It's less than 180 degrees. More than half a circle, more than 180 degrees. Semicircle, that's exactly half of a circle. It's exactly 180 degrees. Okay. Let me add one more thing in. If we want to talk about the measure, I'll do that in another thing. I've got it drawn over here. We'll talk about the measure here in a little bit. All right, so semicircle, exactly half a circle, exactly 180 degrees. All right, any questions so far? If you do, maybe jot yourself a note, put a little question mark somewhere on your paper. Ask me in class, okay? But make sure you understand that. Now, let's talk about measurements, okay? So I've got an arc, some arcs drawn here. Let me zoom out just a little bit here. One of these days I'm going to figure out the in and the out part of this camera. All right, here we go. So AC is a diameter. Okay, so if I come from A all the way over here to C, straight across the circle, that's a diameter. We know that from some of our previous lesson, what that term means. Okay, so go ahead and copy this picture down. We've got Q here, so this is called circle Q. I've got B over here, D here. I've got a 70-degree angle and a 100-degree angle. All right. So let's talk about measurements. If I want to find the measure of this arc up here, first off, we're going to talk about arc AB. It's a minor arc. Right? If we want to find the measure of it, just like we did for an angle, we just put an M in front of it. So the measure of arc AB equals something. Super easy. It equals the central angle. That arc equals its central angle. Remember, central angle is an angle whose vertex is at the center point. So this arc equals 70 degrees. Really, really simple. Okay, well, what about the measure of arc BC? What does that equal? All right, well, BC would be this one right here. It's a minor arc again, less than half circle. It's going to equal its central angle. Well, I don't know that central angle, right? I don't know what that is. But we do know that these two together, because this is a diameter is a straight line, and what do we know about straight lines? These angles add to equal, hopefully you were thinking 180 degrees, or you can even say it out loud, even if your parents look at you weird while you're watching the video or something, it's no big deal. Okay, so these equal 180 degrees, so this is 110 degrees. 180 minus 70 is 110. Hopefully you can see that. I'm going to zoom in a little bit here so you can see that better. Okay, 110 degrees. So if this arc that we were talking about, BC, has to equal its central angle, then over here I can say it equals 110 degrees. Okay, that's pretty simple, right? Okay, well, what about arc AD? Okay, this one up here. How much is it? Well, it equals its central angle. I don't know how much that is. Can I do this equaling 180, these two? No, that's not a straight line. From D to Q and then out to B here is not a straight line, so I can't do that. But I do have another, I remember I got this straight line, this diameter, so these two angles together equal how much? Right, they got to equal 180 again, so this is going to be 80. Okay, so that means up here, this arc, the measure of arc AD equals 80 degrees. I remember we said minor arcs, 2 letters, are always less than 180 degrees. Alright, well, let's look at some arcs that are major arcs. Okay, so major arc. What about arc BCD? Okay, if I start at B, and I work my way through C, and I end up here at D. Okay, that's arc BCD. So how would I find its measurement? Well, we already know that this is how much? It's 110, right? And this one is 100. So what do you think you could do to those two numbers to get this whole thing? Hopefully you're thinking, I could add them, right? 110 out here, 100 over here. Those arcs together equal, put our M for measure, measure of arc BCD equals 210 degrees. Okay, it's a major arc. It's more than 180 degrees. Okay, it's more than half of the circle. All right, well, what about a semicircle? Remember, a semicircle is exactly half of the circle. So where could we start in this picture if we wanted to do exactly half of a circle? Where could we start? Hopefully you said we could start at A, or maybe you said we could start at C. Well, we could. We could start at A or C, and then we're just going to end at the other one. So if I start at A, I'm going to end at C. If I start at C, I'm going to end at A. Now, if I just told you arc AC, that's all I wrote down, would you really know what I'm talking about? Does that mean this arc AC, or does it mean this arc AC? They're different arcs. Now, they equal the same thing. 80 plus 100 is 180. 70 plus 110 is 180. So coming this way is 180. Coming this way is 180. So they equal the same amount, but they are different arcs. So you cannot just use two letters, okay, for a semicircle. So if I want this one over here, how do you think we'd name this one over here? Well, start with A or C, it doesn't matter. Go through B, and then end at the other one. So arc A, B, C is how we'd write that one. That's this one right here, ABC. Measure of arc ABC equals 180 degrees. This is a semicircle. Okay, so how would we name this one over here? Okay, let's say you start down here. Start down here and name it. C, D, A. So the measure of arc CDA would equal 180 degrees. All right, one last one on this one. What if I asked you to find the measure of arc ADB? Okay, the measure of arc ADB. Let me zoom out just a tiny bit so you can see the whole circle all at the same time. Okay, measure of arc ADB. Okay, so we're going to start at A. We're going to come through D. We're going to keep coming around until we finally end at B. I just happened to go through C. I didn't name it. We don't need to use four letters. Okay, I'm going to go there. So it's really A to D and all the way around until I finally stop at B. Now I could have named that as A, C, B, and it'd be the same arc. Okay, you just can name it slightly different. That's fine. All right, so what would we do? Well, we knew this one was how much? That one was 80, right? We know this one is 100. We know this one is 110. So what am I going to do to all those numbers? I'm just going to add them together. 80 plus 100 is 180. 180 plus 110 is 290 degrees. Now, the other way we could do is we could say, well, I have a whole circle, except I don't want this part. So 360 minus that 70 would also give me the 290 that I'm looking for. Okay? Is that kind of making sense, I hope? If not, write something down, ask me a question when we get to class. Okay? Now, what we've actually been doing here is arc addition. The arc addition postulate says you can add adjacent arcs together to get bigger arcs. Okay? You can add arc DA plus arc AB to get arc DB. Or you can add arc DA plus arc ABC to get arc DAC. You can add adjacent arcs together to get bigger arcs. We did that earlier with segment addition and angle addition. We added segments together to get bigger segments as long as they were adjacent and in a nice straight line. We could add angles together to get bigger angles as long as they had the same vertex and they were adjacent. They were right next to each other. Same thing here. They have to be in the same circle and as long as they're adjacent. What you can't do is you can't say, well, I'm going to add arc DB plus arc AC. Well, we can't do that because this kind of got overlapped there. Arc DB and then arc ABC, this overlapped. Or I can't say I'm going to add DA plus BC. They're not adjacent. We skipped this whole section here. Okay, so they have to be adjacent. They can't overlap, but as long as they're adjacent, they're not overlapping or anything like that, you can add smaller arcs together to get bigger arcs. Okay? All right, last couple things. Congruent circles. All right, congruent circles is pretty easy. How do you tell if you have congruent circles? There's two ways. That's a radius, remember? I'll zoom in on this. That's a radius. And I still can't figure it out. All right, congruent circles. And then I've got another one over here. I got a radius there. What do you think would need to be true about these two circles in order to say they are congruent? Well, the circles would have to be the same size, right? Well, how do we really tell the size of a circle? What's the easiest thing to tell? Well, the easiest thing to tell is their radius. Congruent circles will have congruent radii. Remember, radii is plural for radius. Congruent circles have to have congruent radii. You could say congruent circles have to have congruent diameters, and that would be okay. All right? But usually we focus on the radius instead of the diameter. Okay? So pretty basic, pretty easy to tell. Now, if they don't have congruent radii, then they are not congruent circles. That's that simple. Very, very, very easy. All right, finally, congruent arcs. This has two different pieces to it. Okay, so let me explain this one, and then we're going to be pretty much done. All right. Congruent arcs, two things. Number one, congruent circles. Number two, same measure. Okay, in order to have congruent arcs, we must have congruent circles and the same measure. Technically, you could have the same circle. Okay, I'll explain that here in a second. Okay, so congruent circles or the exact same circle. Okay, and then you gotta have the same measure. So let me show you what I mean by that. Let me grab a new sheet of paper. All right, so let's talk about that same circle thing. So let's say I have something like this. These angles are congruent by vertical angle theorem. Okay, talked about that a long time ago, way back at the beginning of the year. All right, so those are congruent by vertical angle theorem. All right, so this arc up here, we'll use some letters, W, X, Y, and Z. We can say that arc WX is congruent to arc YZ. They're in the same circle, and they have to have the same measure, because remember, the measure of this equals this angle, and that angle are equal by vertical angles. So that measure equals that. So by transitive property, we can get from here all the way to here. All right, so these are congruent arcs. Now, the more common way you're going to see congruent arcs is in different circles. So you might get something like this. 90 degrees, and we'll say that this radius is 8 inches. Okay, and then maybe something like this. 90 degrees and 8 inches. Okay, AB, and we'll call it PQ. Okay, arc AB is congruent to arc PQ. They are in congruent circles, because the circles are congruent, remember, because they have congruent radii. And this is 90, so therefore this out here is 90 degrees. This is 90, so therefore this out here is 90 degrees. So therefore these are congruent arcs. Same measure, congruent circles. Now what you're going to get sometimes is you're going to get things that you think might be congruent arcs, but they are not. Let me show you an example of that. Let's say we have something like this. All right. Let me draw a circle here real quick with my compass. Okay, and let me draw another one. I'm going to use the same exact center point. Let's kind of start looking like a bullseye. If you remember our correct term from lesson 1, think about this while I'm drawing it. What kind of circles have the same center point? Do you remember what kind of circles? What was that term? Circles with the same center point that looked like that. Let me draw one more. Alright, so got a couple circles here with the same center point. Now I'm going to draw a diameter right through all of them. There's my center point. Diameter all the way across. So that actually is a diameter from here to here. It's a diameter from here all the way over to there. Or a diameter from here all the way over to there. So this big arc right here is 180 degrees. This arc right here is 180 degrees. This arc right here is 180 degrees. I could draw another one down in here, 180 degrees. Are these congruent arcs? Hopefully you understand the answer is no. Remember, what was our definition for congruent arcs? Let's look back at it. Congruent arcs, congruent circles or the same circle, and they have to have the same measure. Okay, do all these have the same measure? 180, 180, 180. Yes, obviously they all have the same measure. Are they incongruent circles? Well, how do we check for congruent circles? They have to have congruent radii. Is this radius right here equal to that radius? No, obviously not. What about this one compared to that one? No, obviously not. Okay, so they're not congruent circles. Or the same circle. No, these are different circles. Okay, they have the same center point, but they actually are different circles. Okay, so these are not congruent arcs. Congruent arcs, congruent circles and same measure. These are not incongruent circles. One of the things that has to be true for congruent arcs is it has to be the same distance as well. We're going to get to distance later on for an arc. These distances are obviously different. If you've ever gone roller skating and you, not that I've ever done this or anything like that, but let's say this is like a roller skating rink, and then you kind of have the straight section until you have it curved down here way at the bottom again. So you get to this end, and maybe you and a couple friends are holding hands, and so this friend kind of comes around here, kind of slow, and they're holding hands with this friend who kind of travels this line, and then there's this friend out here who's like flying around the outside, right? Who travels the farther distance? Well, this guy way out here, right? And, you know, sometimes, like I said, not that I ever did this, but, you know, these people are kind of good skaters, and they're like telling this person who's not a good skater, hey, this is kind of fun, just hang on, we'll whip you around the edge, and then they like let go when he's right about here, and he goes like sailing off into the wall or something. Now, I was usually the guy sailing off into the wall because I was not a good at roller skating, so that was typically me. All right, so these are not congruent arcs because they do not have the same size circle. They are not equal in length. All right, so that's lesson 10.2. All right, so make sure you know these terms again. Central angle, angle at the center point, vertex at the center point, arc. We got minor arcs that are less than half the circle, major arcs that are more than half. 2 letters here, 3 letters here. Semicircles exactly half, got to use 3 letters on a semicircle. Congruent circles have congruent radii. Congruent arcs have to be in congruent circles and have the same measure. And then the arc addition postulate, which is what we did on this circle where we kept adding arcs together to get bigger arcs. That is lesson 2. There's only one video for this lesson.